So I'm going to talk about developing good narratives to structure visual elements. So narrative combined with good visual science communication results in illustrated factual stories. So we're really talking about storytelling within the context of science. And these are based on both the visual and the narrative are based on ancient forms of communication. They're supported by human neurobiology. There are lots of great examples, children's books, film and television, and TED Talks is a really good example of science storytelling. So the fact that narrative and visual communication is ancient is one of the reasons why it's so powerful. We've been telling stories to each other for millennia around campfires in settings, informal and formal, where this oral tradition of telling stories is a way to make memorable impression on people to give them ability to retain these stories. In cultures like nomadic cultures of Australia, it's the only way that the historical record is passed on is through this oral tradition. As well, cave paintings have been around for tens of thousands of years, and which depictions of various features of their environment, as well as telling stories of capturing, game or battles that were fought. The neurobiology basis is being unveiled as in recent research shows. So one of the neuro basis for narrative is an experiment that's been done. Some guy at Princeton's been working on this, where you look at the different parts of the brain that light up under conditions of random video versus a compelling story like an Alfred Hitchcock film, where not only does the brain light up, but everybody watching lights up in a similar way. So it unifies the thinking of a group. In the visual realm, color is one great easy way to capture that, and this is the MRI of people looking at color scans of red versus green versus blue, and you can see that red really lights up in a way that much more than greens or blues, and that has to do with the fact that our blood pressure, our heart rate goes up when we see red, and that's because of danger, like color of blood. An early form of narrative communication goes back to the epic poem of Gilgamesh from 4,000 years ago, and this, involving these kings and gods and this perilous and long journey that Gilgamesh makes to discover the secret of eternal life is a classic and dates back to ancient times. Another example of early communication in the visual sense is stained glass, which was developed by the Egyptians and Romans using metallic oxides in combination with glass to create different colors. Red, of course, is gold is what's used to make red glass, and why it's more valuable and difficult to replace than any other color. Used throughout the medieval period, and was really the only way that people could see color drawings. Tiffany began making residential glasses almost 2 centuries ago, so this is a form that's carried throughout. Nowadays, we can see great examples of illustrated stories like children's books, again, something that we're reared with in early days. And now film and television have really captured, the use of color and telling stories. And so a couple things about why you would want to combine narrative and visuals for science communication. And the 3 big reasons here are that it's engaging for the audience. The stories are more interesting than string of facts, and compelling visuals help illustrate points. And studies show that people are more willing to believe a story than they are facts, independent of that story. It improves retention. It's easier to remember a good story and good visuals. It can shorten the reading time. It's a quicker way to get a message across, and people can view it and follow the storyline quickly. And so you want to look at examples of film and television, but also in the TED Talks, where storytelling is used in TED Talks. And so they use emotion, they make memorable stories, they provide passion, and they use visuals. So it's very, very much in that style of good communication. So the contrast is between narrative storytelling is the logical science communication. So narrative storytelling is where you have specific cases from which you can make generalizations to infer greater truths. The logical science communication model is abstract truths valid across a range of conditions. Storytelling is practical and very place-based, whereas logical science communication is theoretical and not place-based. Narrative stories have similar essential elements. They have cause-effect, they have timelines, they have a temporal component, and they have people involved, particularly one person. So the next thing I want to do is talk about storytelling from Why Science Needs Story, a book called Houston, We Have a Narrative by Randy Olson. And this book I'll refer to for the rest of this introduction. And first there's going to be three templates we're going to go through: the word template, the Dobzhansky template, the sentence template, and but therefore template, and the paragraph template, the logline maker template. So the Dobzhansky template is designed for choosing one good word, one word that captures what the meaning is. And so the template is nothing in blank makes sense except in light of blank. So an example is nothing in biology makes sense except in light of evolution, or nothing in geology makes sense except in light of plate tectonics. So we've employed this template. Recently we were in Rio and looked at the Guanabara Bay, and we had a workshop where we said, well, here in the museum where we're having this workshop, there's a display and it has a huge set of photos that says the Earth is blue, the Earth is unique, the Earth is dynamic, and the Earth is finite. 4 words. And so tell us what you think Guanabara Bay is. And when we got that back from 100 plus people, we had this nice word cloud, which really was helpful and effective in capturing sort of the dynamic of this place, that it was both beautiful and polluted, dynamic and unique, mismanaged, dirty, important. So it gave that the complexity of the issues there. We also did it in a workshop with Chesapeake Bay, and he said, what's Chesapeake Bay? Well, beautiful, iconic, important, productive, big, threatened, all these kind of words that capture the issues associated with Chesapeake Bay. And we can even use this template to ask questions like your vision for the bay. You want it to be healthy, clean, sustainable, productive, restored. The next template is the sentence template, and this is the and, but, therefore. And I encourage you to watch Randy Olson's TED-Med talk on this. It's a short one. And it talks about and, but, therefore as the desired template, a boring template of A, and, just kind of droning on. And then a confusing template, despite, yet, however, where you never really bring it together. Whereas and sets it up, the statement's separated by and, tension, but, and then resolution in a therefore. Now I'm going to dig into this a little bit and give you an example of this narrative power of using and, but, and therefore. An example, first example is Darwin, and he was a 19th century Englishman, influenced by Thomas Malthus's essay on the principle of population, by Charles Lyell, his geology professor, and Alexander von Humboldt, the German explorer who went to South America, among other places. Darwin did make an extended field trip on the Beagle for 5 years. He was in South America and Galapagos. He was a prolific author, lots of books and papers. There's another guy that I want to contrast to Darwin, and really same lifespan overlapped. He knew Darwin. He was another 19th century Englishman, also influenced by the same authors, also went into extended field trips in South America and present-day Indonesia, prolific author. Both of these guys independently came up with the theory of natural selection. And they did it and went, wow. Wallace submitted his paper from Malay Archipelago, and Darwin received a copy of it, was encouraged by his friends to co-submit because he had had these ideas for 20 years, hadn't published it. So in 1858, in July, at the Linnaean Society, there was this great experiment where they both presented the same theory at the same time with the same influences and the similar observations. So whose theory who do we attribute the theory of natural selection to today? Not Wallace, but in fact Darwin. So we compared their ability to use this narrative structure, and we did this by Randy Olson and I developed this narrative index, which is the number of buts versus number of ands. We also count the number of therefores, but there are a lot of synonyms to therefore, and but is much more common words, and so it was easier and better to we found to just use those two words and come up with a simple quantitative index. Number of buts divided by number of ands times 100. So Wallace came up in that co-submitted journal article with a narrative index of 19, whereas Darwin came up much higher, 27 and 26, in the two submissions he had in the same journal. Now that's a small sample size, so we went and looked at 3 books by both authors. Wallace had a 2-part book on the Malay Archipelago, volume 1 and 2, narrative index 11 and 12, and a book called Island Life, consistently about 14. Darwin, in his first 3 books, The Voyage of the Beagle, the Coral Reef book, and The Origin of Species, much higher narrative index, 17, 17, and 20. So Darwin was a better storyteller than Wallace, and of course Darwin's the one that we remember, that we attribute to this great breakthrough in thinking. Interestingly, Darwin is buried in Westminster Abbey. Wallace has a medallion next to Wallace's crypt, but doesn't have the fame or attribution that Darwin was able to achieve. So we applied this to another comparative set of speakers, in this case non-scientists, and this was Everett, a senator, and Abraham Lincoln, the president. And this was at Gettysburg in 1863. After the battle, there was an event to dedicate in the battlefield to dedicate a portion of that field, and they both gave speeches. Everett gave a 2-hour speech, 13,000 words, with a narrative index of 8. Lincoln gave a 2-minute speech, 272 words, the famous Gettysburg Address, much higher narrative index. And Everett concluded by saying, "I should be glad if I could flatter myself that I came as near to the central idea of the occasion as 2 hours as you did in 2 minutes," in a letter to Lincoln. And if you look at Lincoln's Gettysburg Address, one of the most famous American speeches, it in fact very much follows an ABT format. 407 years ago, blah, 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 conceived in liberty and dedicated to the proposition, inferred the word but. We are now engaged in the great Civil War testing with that nation, blah, blah, blah. Therefore, it is for us, the living, rather to be dedicated here to the unfinished work, etc. So, good narrative structure is compelling. In looking at the Lincoln-Douglas debates, Randy Olson analyzed those 7 debates. Lincoln consistently beat Douglas, and this is after Douglas had already defeated him as a senator. This was the presidential debates where Lincoln had a narrative index of 20, Douglas less than 10. So how to tell the story become much more compelling. We went and looked at, and Dylan was helping with that, the Nobel lectures. We looked at physics versus literature for the entire time that they've been awarded. Physics lectures had a narrative index average of 14, whereas literature 21. So literature, much better storytellers than the physicists. Some of the examples are given here, and you can see a wide range, but overall you can see that literature has a compelling need to use narrative. Science, not as much. And then if you look at this plotted out on a frequency histogram, you see that there are very few literature, the red, that are narrative index below 10. Lots of scientists below 10, very boring, and a lot more literature skewed in the higher range narrative indices. So that's very telling. So this and but therefore is a very powerful template. Now the paragraph template, which we call the logline maker template, is based on this Joseph Campbell's hero's journey. And this is where you start out in the known world, and you get this call to adventure, and then there are a journey that you take in this clockwise, and you often have a mentor like a Yoda telling you, what to do. You have helpers, you have challenges and temptations, and then you get to this abyss where things look bad. The heroes, not looking good, and then there's a transformation and an atonement, and ultimately a return, like the Wizard of Oz, return to the known world, but in a different mindset. You've really changed. You've been transformed in this process, in this hero's journey. So in Randy's book, he's got a series of a template. In an ordinary world, blank, a flawed character, blank, has a catalytic event, blank. The character upends the world, but after taking stock, blank, the character decides to take action. But when the stakes get raised, blank, the character must learn the lesson, blank, and to overcome the opposition, blank, and achieve the goal. So you can just tell the story in this hero's journey kind of fashion. So you might think that most of those stories, and like Wizard of Oz or the Star Wars trilogies, or that's fiction. But science has no place. Story has no place in science. But in fact, it does. Science and storytelling are linked, and two great science philosophers, Karl Popper and Peter Medawar, say this about telling stories. Popper says it's one of the novelties of human language that encourage storytelling and thus creative imagination. Scientific discovery is akin to explanatory storytelling, to myth-making, and to poetic imagination. Medawar says scientific theories begin as imaginative constructions. They begin, if you like, as stories, and the purpose of the critical or rectifying episode in scientific reasoning is precisely to find out whether or not these stories are stories about real life. So, stories are important in telling science. It's Popper's talking about poetic imagination. Medawar's talking about imaginative construction. So use your imagination in telling these stories, but use data. Scientific data does show trends, but that doesn't provide a compelling story. The story is in there, and we have to figure out how to tell that story. So this is a website that we created to report our annual Chesapeake Bay report card results, and then tracking over time the various indicators. But when we were challenged by a former governor of Maryland to turn those data into stories, we created a new and different website, which is to tell the story behind this, what's going on in Chesapeake Bay. And I like this quote: "Stories are just data with a soul." So you're just providing the data, but you're telling how that data interrelates. So little tagline like in the 2013 report card, "It's not the rain, it's what the rain carries," was part of how to tell that story. So the challenge for us is to collect good data, but take that data and turn it into good and compelling scientific stories.